Welcome back to the second in the video series of basics of electrolysis, where we shall be looking at the different forms of an electrolyte. In the first video, we've established that an electrolyte is a compound in either the molten or aqueous form that allows current to flow through it. And we looked at kitchen salt when melted or dissolved in water as an example of an electrolyte. So in this video, we want to go a little deeper and identify some major differences between these different forms of an electrolyte, right? A theory called the ionic theory, the modern version of it, states that an electrovalent substance like sodium chloride or any other salt like calcium chloride consists of ions. For instance, sodium chloride consists of positive sodium and negative chloride. But in the solid form, these ions are locked together by a force of attraction, which we saw in the earlier video. We found out that it was possible to separate out these ions and by either heating the substance or by dissolving it in water. Now, the process by which a compound that consists of oppositely charged ions separate out, that is, in other words, it's a process by which a compound like sodium chloride that consists of oppositely charged ions have the ions separated out is called ionization. In a nutshell, ionization is the breaking of a compound into its component ions. All right. Now, if we are talking about molten sodium chloride, which we obtain by simply taking your electrolyte, like e.g. our kitchen salt, and putting it in a frying pan and heating it to a very high temperature, the only ions we will have to contend with are the ions coming from the electrolyte as shown in the diagram. You can see this is my sodium chloride and put in a frying pan and I'm heating it up. It splits into sodium ion and chloride ion. The only ions I have are the ions coming from the electrolyte. Now, on the other hand, if I take my sodium chloride and dissolve it in water, I will have the aqueous form of the electrolyte, the aqueous form of sodium chloride. So aqueous sodium chloride is sodium chloride in water. Now there's going to be a big difference between the ionization. Here, in the molten case, the only ions I had to contend with were the ions coming from the electrolyte. But here now, apart from the electrolyte ionizing, in this case sodium and chloride ions, the water I'm using as a solvent will also ionize to give hydrogen ion and OH minus. And in subsequent videos, when we come to look at the electrolysis of the aqueous form of the electrolyte, we are going to see how these, the introduction of the ions from water affect the products that are formed. Now, we can also vary the aqueous form of the electrolyte by looking at the quantity of the water we use for dissolving the sodium chloride. If the quantity of water is much, we call that aqueous, as we said earlier on. However, it's possible for us to use just a little quantity of water. In that case, we will call it the concentrated form of the sodium chloride. Now here, what ions are we going to have? The sodium chloride, which is our electrolyte, will as usual ionize to form sodium ions and the chloride ions. The water, which is still there, but the difference is that it's not much in quantity, will still ionize to give us the hydrogen ion and the hydroxyl ion, and we indicate it here, very small, very small. Now, when you carry out the electrolysis of a molten form of the electrolyte, the aqueous form of the electrolyte, and the concentrated form of the electrolyte, the product you get is going to be different. In other words, if I carry out the electrolysis of molten sodium chloride, as we shall see later, you're going to find out that what you will get at the anode will be chlorine gas, what you will get at the cathode will be sodium, we shall see that later. Then for the aqueous form, the products change. In other words, as the form of the electrolyte changes, the product also changes. And that is why whenever we want to carry out the process of electrolysis, we have to put into cognizance the forms of the electrolyte. Thank you very much for tuning in. If you've liked the video, if you benefited from it, please like it, subscribe, share to as many people as possible. And of course, not forgetting, if you have any questions, or ideas or suggestions, please drop it in the comment section, and we promise that we're going to look at it. Thank you very much. Hope to see you in the next